and good morning. Appendix 13 of Edison, His Life and Inventions. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Heidi Preuss. Edison, His Life and Inventions by Frank Louis Dyer and Thomas Commerford Martin. Appendix 13. Edison's Electric Railway. As narrated in Chapter 18, there were 2 electric railroads installed by Edison at Menlo Park, one in 1880, originally 1/3 of a mile long, but subsequently increased to about a mile in length, and the other in 1882, about 3 miles long. As the 1880 road was built very soon after Edison's notable improvements in dynamo machines, and as the art of operating them to the best advantage was then being developed, this early road was somewhat crude as compared with the railroad of 1882, but both were practicable and serviceable for the purpose of hauling passengers and freight. The scope of the present article will be confined to a description of the technical details of these 2 installations. The illustration opposite page 454 of the preceding narrative shows the first Edison locomotive and train of 1880 at Menlo Park. For the locomotive, a 4-wheel iron truck was used, and upon it was mounted one of the long Z-type 110-volt Edison dynamos with a capacity of 75 amperes, which was to be used as a motor. This machine was laid on its side, its armature being horizontal and located toward the front of the locomotive. We now quote from an article by Mr. E. W. Hammer, published in The Electrical World, New York, June 10, 1899, and afterwards elaborated and reprinted in a volume entitled Edisonia, compiled and published under the auspices of a committee of the Association of Edison Illuminating Companies in 1904. The gearing, originally employed, consisted of a friction pulley upon the armature shaft, another friction pulley upon the driven axle, and a third friction pulley which could be brought in contact with the other 2 by a suitable lever. Each wheel of the locomotive was made with metallic rim, and a center portion made of wood or papier mâché. A 3-legged spider connected the metal rim of each front wheel to a brass hub upon which rested a collecting brush. The other wheels were subsequently so equipped. It was the intention, therefore, that the current should enter the locomotive wheels at one side, and after passing through the metal spiders, collecting brushes, and motor, would pass out through the corresponding brushes, spiders, and wheels to the other rail. As to the road, the rails were light and were spiked to ordinary sleepers with a gauge of about 3 1/2 feet. The sleepers were laid upon the natural grade, and there was comparatively no effort made to ballast the road. No special precautions were taken to insulate the rails from the earth or from each other. The road started about 50 feet away from the generating station, which in this case was the machine shop. 2 of the Z-type dynamos were used for generating the current, which was conveyed to the 2 rails of the road by underground conductors. On Thursday, May 13, 1880, at 4 o'clock in the afternoon, this historic locomotive made its first trip, packed with as many of the boys as could possibly find a place to hang on. Everything worked to a charm until, in starting up at one end of the road, the friction gearing was brought into action too suddenly, and it was wrecked. This accident demonstrated that some other method of connecting the armature with the driven axle should be arranged. As thus originally operated, the motor had its field circuit in permanent connection as a shunt across the rails, and this field circuit was protected by a safety catch made by turning up 2 bare ends of the wire in its circuit and winding a piece of fine copper wire across from one bare end to the other. The armature circuit had a switch in it which permitted the locomotive to be reversed by reversing the direction of current flow through the armature. After some consideration of the gearing question, it was decided to employ belts instead of the friction pulleys. Accordingly, Edison installed on the locomotive a system of belting, including an idler pulley which was used by means of a lever to tighten the main driving belt, and thus power was applied to the driven axle. This involved some slipping and consequent burning of belts. Also, if the belt were prematurely tightened, the burning out of the armature. This latter event happened a number of times, and proved to be such a serious annoyance that resistance boxes were brought out from the laboratory and placed upon the locomotive in series with the armature. This solved the difficulty. The locomotive would be started with these resistance boxes in circuit, and after reaching full speed, the operator could plug the various boxes out of circuit and in that way increase the speed. To stop, the armature circuit was opened by the main switch and the brake applied. This arrangement was generally satisfactory, but the resistance boxes scattered about the platform and footrests being in the way, Edison directed that some No. 8 B and S copper wire be wound on the lower leg of the motor field magnet. By doing this, the resistance was put where it would take up the least room, and where it would serve as an additional field coil when starting the motor, and it replaced all the resistance boxes which had heretofore been in plain sight. The boxes under the seat were still retained in service. The coil of coarse wire was in series with the armature, just as the resistance boxes had been, and could be plugged in or out of circuit at the will of the locomotive driver. The general arrangement thus secured was operated as long as this road was in commission. On this short stretch of road there were many sharp curves and steep grades, and in consequence of the high speed attained, as high as 42 miles an hour, several derailments took place, but fortunately without serious results. 3 cars were in service during the entire time of operating this 1880 railroad, one a flat car for freight, one an open car with 2 benches placed back to back, and the third a box car, familiarly known as the Pullman. This latter car had an interesting adjunct in an electric braking system, covered by Edison's patent number 248430. Each car axle had a large iron disc mounted on and revolving with it between the poles of a powerful horseshoe electromagnet. The pole pieces of the magnet were movable and would be attracted to the revolving disc when the magnet was energized, grasping the same and acting to retard the revolution of the car axle. Interesting articles on Edison's first electric railroad were published in the Technical and other papers, among which may be mentioned the New York Herald, May 15 and July 23, 1880, the New York Graphic, July 27, 1880, and the Scientific American, June 6, 1880. Edison's second electric railroad of 1882 was more pretentious as regards length, construction, and equipment. It was about 3 miles long, of nearly standard gauge, and substantially constructed. Curves were modified, and grades eliminated where possible by the erection of numerous trestles. This road also had some features of conventional railroads, such as sidings, turntables, freight platform, and car house. Current was supplied to the road by underground feeder cables from the dynamo room of the laboratory. The rails were insulated from the ties by giving them 2 coats of japan, baking them in the oven, and then placing them on pads of tar-impregnated muslin laid on the ties. The ends of the ties were not japanned, but were electroplated to give good contact surfaces for fish plates and copper bonds. The following notes of Mr. Frederick A. Scheffler, who designed the passenger locomotive for the 1882 road, throw an interesting light on its technical details. By May 1881 I was engaged by Mr. M. F. Moore, who was the first general manager of the Edison Company for isolated lighting, as a draftsman to undertake the work of designing and building Edison's electric locomotive No. 2. Previous to that time I had been employed in the engineering department of Grant Locomotive Works, Paterson, New Jersey, and the Rhode Island Locomotive Works, Providence, Rhode Island. It was Mr. Edison's idea, as I understood it at the time, to build a locomotive along the general lines of steam locomotives, at least in outward appearance, and to combine in that respect the framework, truck, and other parts known to be satisfactory in steam locomotives at the same time. This naturally required the services of a draftsman accustomed to steam locomotive practice. Mr. Moore was a man of great railroad and locomotive experience, and his knowledge in that direction was of great assistance in the designing and building of this locomotive. At that time I had no knowledge of electricity. One could count so-called electrical engineers on his fingers then, and have some fingers left over. Consequently, the electrical equipment was designed by Mr. Edison and his assistants. The data and parts, such as motor, rheostat, switches, etc., were given to me, and my work was to design the supporting frame, axles, countershafts, driving mechanism, speed control, wheels, and boxes, cab, running board, pilot or cowcatcher, buffers, and even supports for the headlight. I believe I also designed a bell and supports. From this it will be seen that the locomotive had all the essential paraphernalia to make it look like a steam locomotive. The principal part of the outfit was the electric motor. At that time motors were curiosities. There were no electric motors, even for stationary purposes, except freaks built for experimental uses. This motor was made from the parts, such as fields, armature, communicator, shaft, and bearings, etc., of an Edison Z, or 60 light, dynamo. It was the only size of dynamo that the Edison Company had marketed at that time. As a motor, it was wound to run at maximum speed to develop a torque equal to about 15 horsepower with 220 volts. At the generating station at Menlo Park, 4 Z dynamos of 110 volts were used, connected 2 in series in multiple arc, giving a line voltage of 220. The motor was located in the front part of the locomotive, on its side, with the armature shaft across the frames, or parallel with the driving axles. On account of the high speed of the armature shaft, it was not possible to connect the driving axles direct, but this was an advantage in one way, as by introducing an intermediate countershaft, corresponding to the well-known type of double reduction motor used on trolley cars since 1885, a fairly good arrangement was obtained to regulate the speed of the locomotive, exclusive of resistance in the electric circuit. Endless leather belting was used to transmit the power from the motor to the countershaft, and from the latter to the driving wheels, which were the front pair. A vertical idler pulley was mounted in a frame over the belt from motor to countershaft, terminating in a vertical screw and hand wheel for tightening the belt to increase speed, or the reverse to lower speed. This hand wheel was located in the cab, where it was easily accessible. The rough outline sketched below shows the location of the motor in relation to countershaft, belting, driving wheels, idler, etc. On account of both rails being used for circuits, the driving wheels had to be split circumferentially and completely insulated from the axles. This was accomplished by means of heavy wood blocks, well shellacked or otherwise treated to make them water and weatherproof, placed radially on the insides of the wheels, and then substantially bolted to the hubs and rims of the latter. The weight of the locomotive was distributed over the driving wheels in the usual locomotive practice by means of springs and equalizers. The current was taken from the rims of the driving wheels by a three-pronged collector of brass against which flexible copper brushes were pressed, a simple manner of overcoming any inequalities of the roadbed. The late Mr. Charles T. Hughes was in charge of the track construction at Menlo Park. His work was excellent throughout, and the results were highly satisfactory so far as they could possibly be with the arrangement originally planned by Mr. Edison and his assistants. Mr. Charles L. Clark, one of the earliest electrical engineers employed by Mr. Edison, made a number of tests on this 1882 railroad. I believe that the engine driving the 4Z generators at the power house indicated as high as 70 horsepower at the time the locomotive was actually in service. The electrical features of the 1882 locomotive were very similar to those of the earlier one already described. Shunt and series field windings were added to the motor, and the series windings could be plugged in and out of the circuit as desired. The series winding was supplemented by resistance boxes, also capable of being plugged in or out of circuit. These various electrical features are diagrammatically shown in Figure 2, which also illustrates the connection with the generating plant. We quote again from Mr. Hammer, who says, "The freight locomotive had single reduction gears, as is the modern practice, but the power was applied through a friction clutch. The passenger locomotive was very speedy, and 90 passengers have been carried at a time by it. The freight locomotive was not so fast, but could pull heavy trains at a good speed. Many thousand people were carried on this road during 1882. The general appearance of Mr. Edison's electric locomotive of 1882 is shown in the illustration opposite page 462 of the preceding narrative. In the picture, Mr. Edison may be seen in the cab, and Mr. Insull on the front platform of the passenger car." End of Appendix 13.